Alright, so here's our goal. This week I want you to redo the midterm exam, but with slightly different rules. So to get us started, I'm going to do the entire midterm programming project together with you on this video. And then afterwards, I want you to go clone Lab 5, which is essentially the same project with some minor changes to the rules. And along the way, as we're building this, I want you to think of how you can improve what I'm writing, because in this attempt to write this program, I'm focusing on just getting it done as fast as possible in kind of a way that I'm imagining a 120 student would do it. So over here, I've already cloned it, and it is this folder right here. So let's go inside, and I have the two files there. I'm just going to open it up in my text editor, and I want to look at both files because in the README, there's a very important part that I want to look at, which is this example portion right here. This is very useful for me because it will minimize my typing. I can use the strings here, and it also gives me some way of understanding how the rules work. Now, before you start programming this, it's important that you read the README very carefully. Now, I can understand that if you on an exam you might get stressed out, you might think that you don't understand these things, but it doesn't stop you from asking me questions. And I know that the distance between us is increased. It doesn't stop you from writing me emails or contacting me via Zoom or reaching out to your SI supplemental instruction leaders or your ILAs. Okay, so you've read the README. You understand how the game plays. We're going to now start writing the program. First thing you want to do is fill out the header. I see a lot of students that are not doing the header, and that is not good. It's a good practice to put your information into a file. So this is a single die game pig. Yes, it's going to be quite exciting watching me type, and I'll try not to talk to myself. First up, we want to look at the entire program. We see we've got our header files, so the header files are all the pound includes that are right up here. We're using namespace standards so that we don't have to type std:::, in front of everything. If we come up with any global variables, this is a good spot to put them. Already I can think of a few global variables that we might want to use, but I'll come back to that in a second. Here is where we've got a function defined, and we can add more functions right below it if we'd like, as the comment suggests. And then we have our main, and it clearly says do not touch this portion, so we're not going to touch it. Instead, we're going to fill out our program here. What I like to do is start by thinking about how this program is going to work. Well, it is a game, so it's going to be infinite loops. So it's going to have either do while or while loop. I'm thinking here that I'll start with a do while, and if I need to change it, I can always go back and change it. Why am I using true? I'm using true because it's an infinite loop. You play forever. And then roughly speaking, the player goes first and the computer goes second. Okay, so how would this work out? Well, if we look at the example, I'll switch over to the README. You're going to get a whole bunch of stuff printed out first, which is all this text here. It starts at the rules and comes out to here. It's your turn first, then the computer, get ready. And now here's where the game starts. So this is where we're printing this out from the player's perspective. And there's two different sections. There's this section that I've highlighted. So I'm going to copy this and pull it over here. That's a successful roll, right? So you've successfully rolled the dice, got some points, and it's summing it up and asking if you want to play again. And the other thing that could happen to the player is you roll a 1 or a 6, and it prints that out, the text that I've just highlighted. So I'm going to bring that over here, and I'll put that here. Now, I know the formatting is not great, but these are just notes to myself to help me remember what each one does. And I'm using control bracket to do the indentation. Indentation is super important. Now, what does the computer do? Well, if I'll come and look at the example, it's kind of similar where the AI rolls something and it's totaled up, chooses to roll again. Remember, that's one of the rules. The AI always chooses to roll again. And otherwise, it can lose if it rolls a 1s and 6. So I'm going to copy those strings over here. Oh, forgot to do the comment. Okay, so we've got this idea of like infinite loop. The player's going to go first, then the computer, then we repeat the whole game over again. I know this is just roughing things out, but it's giving us some scaffolding as to what this program is going to look like. Do we need any variables? Yeah, definitely. The way I'm imagining is the dice will roll. You're going to take the score that you get from the dice and look to see if you get one of the special scores, which is 1 or 6. If it isn't, then you total it up to the player score or the computer score, and then continue on. Now, if you score a 1 or a 6, then we need to break out and go on to the next step. So I'll make a variable called, let me move that out of the way, current roll. I want to initialize this to, well, actually, I don't want to initialize it to anything because it's going to get initialized when I run my loop. And I'll need to have another one that's called player score, and another one that's called computer score. And I think that's a pretty good starting point. Now let's think about how this works. So if the player goes first, the first thing the player does is roll the dice. So current roll is equal to, here's where we can go back up to that function and say, can we make it work? Oh, easy. This is just going to use rand. Rand returns some random number that's really big. We need to make it small. And we want the numbers between 1 and 6. I do remember how to do it with modulo, where if I do it with mod 6, it will return something between 0 and 5. Now, if it returns something between 0 and 5, a quick fix for that is to add 1 to it. So let's go over that again. I'm going to take the random number. I'm going to mod it by 6. That's going to give me a number that's either 0, 1, 2, 3, or 4, or 5. Add 1 to it, which will make it the numbers 1, 2, 3, 4, 5, or 6. And since it's a random number, so to speak, it's like rolling a die. So roll 1 die, that's the function I'll use over here. Oops. So now we've got the current roll. Okay. Well, one way of looking at this is we can check for the numbers 2, 3, 4, and 5, or we can just check for the numbers 1 and 6. And we can check using ifs and elses, or we can check using case switch statements. To make it straightforward, I'll just use an if statement. So, and I'll go with the situation of 1 and 6. So if current roll is equal to 1, or current roll is equal to 6, well, this is a bad roll. The alternative, this would be a good roll. Oops, I wrote roll. So in this one, you score points. Now for scoring points, do I have a variable to score the points with? Yes, I have player score. So, oh, but player score is not initialized. I need to set that equal to 0. I'll set computer score equal to 0. I'll come back over here and I'll say player score plus equals current roll. So now I have that score. And here's where I can reuse those strings. So I'm going to paste that here. I'm going to say cout, you rolled. Well, it wasn't a 3. We don't really know what it is, but we have a variable that represents it. Current roll. Your total is, well, we've got another variable that represents that. That is player score. The AI's total is, again, we don't really know what that is, but we have a variable that represents it, and that is computer score. don't forget the \n. It's nice to be formatted nicely. It's good to do our formatting. Okay, now we also need to, well, if we had a good roll, we need to ask, do you want to roll again? Don't forget. Oh, here we don't want a character term, we want a space, so it looks like what we had in the example in the README. Oh, and I need another variable here because I need to capture the player's choice. Does the computer have a choice? No, because the computer always rolls again, so we only need to have a variable which is player's choice. So we'll say string player choice. I don't need to initialize it because it's always going to be initialized to something when I use it. So I'll say cin, oops, not score, player choice. Ooh, okay, now I have to check to see if it's H or R. Well, I can always just check to see if it rolls again, and if it's not roll, R, then I'll just assume it means hold. And I want to do that with a const. So I'll come up here to the top, and I'll say string, and I'll say roll, and that's equal to an R. Now notice that I'm using the double quotes because I want to use a string. Now if you want to use a char, that works as well too. I'm just being wasteful and using a string. Both of them end up being the same. Oh, and while we're here, why don't we set our max score? Remember the rules said it's 30. That's global for everything, so why don't we just set it here? And while we're at it, I think if we look at the example, we have to type in an H and an R, right? That's right here. Is there anything else that we need to type? H and R's. Oh, here we've got. Would you like to play again? Yes and no. We can do the same thing over here, where I can say const string. Oops. Yes is equal to y. And we'll just assume that if they don't say y, they mean no. And we'll get to that later. So going back down here, we got player's choice coming in there. Now they're going to type H or R. We need to check to see what happens. So if player choice is equal to, oh, here's where we can use that variable, yes. Well, we know that if they did that, they want to roll again. Oh, not yes, but sorry, I got them confused. Roll. Okay, let's think about how this is going to behave. So if they want to roll again, we want to stay in this loop. Now, if they want to hold, we want to break out of this loop. Oh, okay. If we think about this way. We've got a do while loop, which is doing the player, and the computer is going to be a very similar do while loop. So why don't I start working on the computer, and I'll just put X's here. This is a way that I remind myself that this is not finished. I need to come back and fix this. And another way that I can stop myself from making a mistake of a spot that I know I need to go back is I can put the function exit and make it force its way out there. I can also use an assert, which is another function that you can look up to use. But for now, I'll just put X's there to remind me to go back and fix it. Now, I want to do the computer. The computer is going to work the same way, and I don't need these strings. I don't need this comment anymore, so I'm just going to get it out of the way. Now, if the computer goes second and it works the same way with this do, oh, I forgot to put the loop for the player. Is this right? Where is this if? Here's where indentation is important. Let's do another loop right here. Do while, and this is also going to be an infinite loop because we keep on doing this until they release it. So I'm going to indent all of this here. That look right? Now I'm playing fast and loose by typing all this code and not compiling, but I'm pretty sure I've got everything syntactically correct. Oops, and I just closed it accidentally. Let me open that up. Let me just try compiling it just to see what's going on. Ah, pretty good. No mistakes. Okay, so I'm going to do the same thing for the computer. So I see everything as a loop for the player. They're going to continue until they decide to hold or roll again. Or actually, they're going to continue as long as they hit roll again, or they get the 1 and 6. So here I need to add stuff here too. Because if they roll a 1 and 6, I forgot to fill in that body there. But why don't we work on the computer for just a little bit? So if the computer goes second, I'm going to do the same thing. I'm going to do a do with a while loop here, and we'll just do this one as an infinite loop as well. And it's going to follow the more or less the same logic. I'll try to get everything on the same window here. We're going to get the current roll because the computer rolls the dice too. And then we're going to check to see if the current roll is equal to 1 or the current roll is equal to 6. This is a bad roll. And we haven't figured out how to do this on the other one yet. Oop, and I keep on misspelling bad roll. So I'll just put some X's there. And then else, well, this is a good roll. We score points here. So this is not going to be the player score, it's going to be the computer score. And we're going to add to it the current roll. And here's where those strings come in handy again. So we're just going to copy that, paste that there. So the AI rolled, and this is where we say current roll. Your total is, and this is where we say player score. And the AI's total is 14, or we can say the computer score. Oh, and I forgot the insertion operator. That looks about right. And the AI always chooses to roll again, so there's none of that if statement stuff above where we have to ask ourselves, do we want to play again? The AI chooses to roll again, and here's where it would go to the bottom of the while loop, go back up to the top, roll the dice again, and do it over and over again unless it hits a 1 or 6. Now if it hits a 1 or 6, let's work on the computer here. If it rolls a 1 or 6, what should we do? Well, all we need to do is break out of this loop and it goes back up to the upper loop. So we'll use the break keyword, and we're going to say that we got to print this message out too, but we got to say that first. So we'll print out our message first and then we'll break. And print out the totals for both of us. See the light at the end of the tunnel. This is coming together quite nicely. Oops, typed that wrong. And then break. So that would send us back up to the upper loop. Let's just check by compiling to see if we got things working. Ah, good, no errors so far. All right, we don't need these here anymore, so I'm going to get rid of that. Going back up to here, let's go back to our X's. Right, so bad roll. Oh, I got rid of that string. I should have gone back. I got rid of it too soon. I need a string that looks like that. I'll copy that string here, come back over to pig.cpp, and if they roll the wrong thing, well, if we roll the wrong thing, we need to print a message out for the player. Says that they rolled a 1 1 or 6. And then we print out their scores. Now, if you think it's really repetitive, I agree with you. This is pretty repetitive. We can make it less repetitive by writing functions. But I'm just trying to focus on keeping this as simple as possible. So the repetitiveness comes with keeping it simple. But also the repetitiveness can make it error prone. So typically I wouldn't be too excited about doing it this way, but I think we're going to be able to write this program pretty quickly. And then if we want, go back and refactor it and make it into functions. Okay, does that make sense? I roll a 1 or a 6, prints out a message letting me know that I rolled a 1 or 6, tells me about the scores, tells me the turn is changing, and it breaks. So if it breaks, it goes out of that do while loop and goes into this do while loop. Then I play there until I hit a 1 or 6, then it breaks out of this one and it goes back up to this one. We're not even checking to see if we win, are we? And we haven't handled this player's choice part here. Well, let's handle the player choice part first. So if they type R for roll again, that means we want to stay in this loop. And if we type in an H to not, let's go look at an example again. So here is when you type R, it just goes into the next one. But on the other hand, when you type in H, it goes to AI turn. Okay, so if, and I've got a little cat problem at the moment, she's really interested in programming. Pardon me. Okay, so if we type an R to roll again, then all we need to do here is we continue. That means stay in this loop, do nothing. On the other hand, if they want to hold, what we do is we break. That would break out of this loop and go to the next loop. Does it make sense? So let's compile. Oh, I made an error. I'm forgetting a semicolon on line 63. Is that right? Before computer score. Oh, I forgot the double angle brackets right here. Let's try compiling that again. Okay, now let's try running it. Oh no. Sorry, the cat typed on my computer. Ooh. So here's another thing that was built into this program. I know I can pass in a number via int argc char star argv. You might have seen that and wondered why am I making it necessary to have that as an option? Well, it's good for debugging. I know if I do 0, I've already done the math ahead of time, and I know how this is going to work out. So I rolled a 2. I can roll again, and I can roll again. This is pretty good. It's working as I expect. Notice that I'm really close. My score right now is 27. Excellent. I won, but it doesn't know that because we didn't put the win state in, because we keep on going. So here, to quit the program, I have to think to myself, how am I going to add the win state in? Where do I need to check? Well, I don't need to check if I roll a 1 or 6. I need to check if I have a good roll. Let's go look at the README again. In the README, they have an example at the very bottom. It says you rolled a 5, total's 33, A has 14, you won. Okay, so after I print that out, I need to check to see if I win or lose. Okay, so notice on this line, on 70, if I win, I don't need to print that out. What I need to do on that line is to say that I've won, and that's where I prompt to see if you'd like to play again. So here's what we got to do. We got to check to see if the win state's right here. So if greater than or equal to, remember we made max score up at the top. To remind you, max score is right up here on line 20, max score is equal to 30. We can change that later. So if player score is greater than or equal to max score, we won. Else, we haven't won, we can still keep playing, so we can do all this stuff over here inside of that. Is that right? Here's where indentation is important. So I did this if. I need to put this else. There we go. Now if I'm not sure, this is the right time to compile, because the compile will catch if I forgot a brace. Ah, perfect. So I got all the braces right. We won here, and for now I'm just going to put a return 0. That's an easy way to spot whether I won or not. And I want to print out a message. Oh, you won. Okay, so we'll just put you won. Don't forget the carriage return. That's the \n. And we can do the same thing over here with the computer. Computer score, computer roll. Right here. So we say if the computer score is greater than or equal to max score, else and here's where we say cout Now, we're not supposed to return 0 here, but it's a good way of like seeing if this works out as a game. So it compiles. Let me run it, and I'll make this window a little bit bigger so that it prints out nicer. So let's roll again, roll again, roll again. Right, the AI got some points there, but they rolled another 1. So let's try it again. Awesome. So that works. We've got a program that works. Now, here's another trick. If I want to make this go faster, I can use the yes program to print out my R's right into the program, and it will take me all the way to the end. That's a fast way to debug, especially if you know what the outcome should be if you've worked it out ahead of time. Now, if I do it with 1, I think no, I won again. If I do it with 2, no, 3, 4, here's an example where the computer won. Now, at your own pace, you can go back through and you can double check to make sure all the logic is correct, but I'm pretty sure with this we've got the right logic and the computer does win because they get just over 30, while our score is just a 5. Okay, so we've gotten this far. Now we want to figure out how to make it play again if we reach the end. This requires a little bit of thinking. So let's think about this. If I'm in here and I get to this part where I won, I now need a way to break out of this loop, which is the player's loop, and not go into the computer's loop because I've won, and then to restart the whole thing all over again. The do while constructs that I use won't work. And the reason it won't work is because if I break out of this loop, where on line 72, if I break out, it will immediately go to line 88, which is the computer's turn, and it will still do the body of that loop at least once before it decides to exit. So to make this work, what I can do is I can make the player be a do while, because the player always has to roll, and make the computer a while loop. This way it allows me to play the person. If the person wins, have them pop out. Now it might not be clear what I'm talking about, but it might become clear in a second. So I'm going to do the while true here, and down here remove the while true, so it now becomes a while loop rather than a do while. This while right here is the do while for the big loop that controls both of these other loops. So I'm going to save that, and let me just compile it again. and I'm going to run it with 0, and it still works fine. If I run it with 4, works fine. So everything's working as I expect. So I didn't make any mistakes in that change. Now here's where we can control how this works. The player goes first. You go into this do loop. Now the player wins. We want a way to break out of this loop and control the next one. Now if I replace the return 0 with a break, what's going to happen is it's just going to pop into the next loop, and it will just do the while loop there until the computer loses or the computer wins or whatnot. What I need to do is turn off the second loop. So what we'll do is we'll make another variable and we'll call it I don't know, game on. We're going to set that to true. Now that I have this variable that represents the game being on or running, I can then go back to this while loop, or this do while loop, change that to game on, this while loop which represents the computer, and make that game on. But I will not touch this other do while loop, which is the big game that controls everything. So, oops, I think I accidentally deleted this line. Oh, what did I do there? I just accidentally pasted that text there. Okay, so we've got that game on variable. What I'm going to do here is where I did that break, where you win, I'm going to say game on is equal to false. If it's false, that means it, and with the break here, it'll break out of this loop, go to this while loop over here on line 90. Then since it's false, it will then not go into that loop and come down to this while loop. Now when it's in this while loop, it'll just go back up to the top and start all over again, but it didn't give us a chance to reset all the values. I need to reset the values here. So if not game on, meaning the game is over, I want to reset the player's score to 0. I want to reset the computer score to 0. And here's where we also need to have something that has it go back up to the top. Am I missing something else? Player score, computer score. Oh, we need to also set game on back to true. But this is if we want to play again. If we don't want to play again, we exit. So let's make another Boolean. And here's where we're going to ask the player what they want to do. I'll go back to the README. I'll copy this text right there. No carriage return on this line. We want to get the player's choice, so cin if player's choice is equal to yes. I think that's what I put at the top. Let's check real fast. Yeah, I have on line 21 right there the string yes. And if we're playing again, we're doing all this. But if we're not playing again, you see how that works? So Now, if we don't want to play again, it will hit this false. It will hit play again equals false, hits this while loop, and exits out, and we end. And if we want to just make it clear to ourselves what's going on, we can add an extra message that we can take out later. Right there. Let's try it. Let's compile, see if we got this right. Ooh, nice. And then let's play it slowly. So, 8.0. Roll again, roll again, roll again. Great, we won. Do we want to play again? Yes. Awesome. So now we start all over again, and the values have reset. Oh, the AI one. But you see something went wrong here where the AI one, we popped right out. So let's go back up to that. I'm glad we tested that. Score. Oh, it's right here because we didn't replace that return 0. So let me look at how I did the player. Oh, I see. Where if the player won, the game on equals false right here. This is what I'm looking at, this line right here. You won, game on's false, and then break. I want to do the same thing over here. The computer won, game on equals to false, and then break. Same idea. It's like a mirror image of one and the other. So let's try this again. Oh, I think I forgot to compile. Great, I won. Let's try playing again. This time the computer should be winning, I think. Perfect. Awesome, everything worked. Okay, so now that I've got all this done, I can save this. Well, okay, so it is saved. I can do one last compile. Good. And I'll do a git status. And I'll push this up to my repository. Done. Okay, so I've just walked you through a really straightforward way of writing this game. Now, it's not the best way to do this because you can see it's really repetitive, and the repetition makes it harder to change the program. But you can see how we can now go back through this program and then identify portions that we can abstract out as functions. But overall, the logic isn't too complicated. I think the trickiest part is how to manage the different while loops, which does take a little bit of thinking. It's not obvious, but with a little bit of work, you can get it to work that way. Now, this isn't the only solution. This is a solution that I thought, given what we've learned over the previous 8 to 10 weeks, this is the kind of solution that you'd come up with. Now, out of the midterms that I looked at, some of you came up with other solutions, like using case switch statements or different layouts of while loops or different types of conditions. These are all very good solutions. But what I want to do is to drive home this idea of writing functions, the conditions, loops. These are the foundations that we need to master so that we can go on to other things. After this lab is done, our next lab is going to focus more on functions and arrays and doing more things with that. And I guess with that, I'm going to stop the recording. And if you have further questions, you can find out more about it on the forum, where I'll post more information about this.